Welcome to qnawire.
So let's say the probability of being a high school dropout is 10.3%. Out of 10 people, we have 10 graduates, and we want to determine the chances of the next 3 questions. So our N is 10. First thing we want to say is we want to know what is the probability that no more than 2 will drop out. So we are looking for the probability that x is less than or equal to 2. So you can use the binomial distribution formula here. And what you have to do is, since you're looking for the probability that x is less than 2, you would have to do x equals 0 plus the probability that x equals 1 plus the probability that x equals 2. Find each of those probabilities separately and add them up. There's easier ways to go about this problem, but I'll show you if we were using the formula, what we would do would be 10 factorial divided by 10 factorial, 0 factorial times 0.103 to the 0 power times 0.897 to the 10th power. And that would be just to find the probability that x equals 0. You would want to repeat that process again for x equals 1, but changing the zeros to 1s, and this 10 would be a 9, and do the same thing for x equals 2. So for x equals 0, I get 0.337. For x equals 1, I get 0.387, and for x equals 2, I get 0.200. When I add those up, I get 0.924. And I would do that by doing the binomial distribution formula 3 times. Another way that I could do that is to put it in the calculator. So I would do a binom CDF. The N is 10. The probability of success is 0.103. And we are looking for the cumulative distribution of up to 2. When I do that, click that in the calculator, I get 0.924. It doesn't matter what method you use to solve it. You're going to get the same answer. It's just that the calculator one requires it into less steps. What is the probability that at least 6 graduate? So for this one, I think it makes more sense to look at if we're trying to find at least 6 graduate. Well, when we look at the problem, it talks about the number dropping out. So if at least 6 graduate, that means that at most 4 students drop out. So I'm going to write it as this. That way I can use the binom cumulative distribution function 10.103 and 4. I would put that in the calculator, and I would get 0.998. I always like to try to write as a less than, so then I don't have to remember that extra step of subtracting from 1. But if you wanted to solve it as x is greater than or equal to 6, you would do 1 minus and be a binom CDF. But remember, since you're looking at the number that graduate there, then you are looking at not the probability of success of 0.103. You want to look at the failure, which is 0.897. And then you always go 1 less, and when you do that, you're going to get the same answer of 0.998. What about looking at the probability that all 10 stay in school? So that means you are looking at the probability that nobody drops out. So I'm going to do this one by hand so you can see how it's done on the calculator, but you might also remember that we already found this probability in a previous example. So 10 factorial divided by 10 factorial, 0 factorial, times 0.103 to the 0 power, times 0.897 to the 10th power. I solve that and I get 0.337. You could also put that in your calculator as a binom PDF because you're just looking for one value. 10.103 and 0, and you will get 0.337.